What's going on, guys? Let's look at this problem right here. Here this question is asking two conducting planes are located at x is equal to 0 and x is equal to 50 millimeter. The zero voltage reference is at x is equal to 20 millimeter. Given that E is equal to negative 110 AX voltage per meter, calculate the conductor voltages. Okay. Now the first thing is we have to know the distance between these two. Like one is at x is at x of 0, x is equal to 0, and the other one is at x is equal to 50. Now they have given the zero voltage reference is at x is equal to 20 millimeter. It means the distance from x of 50, like x is equal to 50 millimeter and x is equal to 0 is 30 millimeter, because the zero voltage reference is at 20 millimeter. So 50 minus 20, 30 millimeter. That's the distance. That's the first thing we have to know. And also the electric field equation is given by E is equal to negative VD, and here it's in the x direction, so AX. So let's call this one equation 1. Now from this one we can find out another equation based on the given informations. Here we have the electric field given, that is negative 110 AX voltage per meter. Negative 110 AX, that's equal to negative VD AX. Here you can see negative cancels each other, so we will get V is equal to 110 D. So this is the equation 2. Now based on the locations we are going to calculate each of that. First let's calculate the first one, the zero voltage one. The location for that one is D is equal to 20 millimeter. And here we know this is the equation we are going to use. 110 times 20 millimeter, 20 times 10 to the power of minus 3 voltage. That will give us 2.2 voltage. Okay. And the next thing is, we know the second one, x of 50, is the distance between these two is 30 millimeter. So that's the second one. V of D is equal to 30 millimeter. That's equal to 110 times 30 times 10 to the power of minus 3 voltage, and that gives us 3.3 voltage. Okay. Now this is the one, and also here you can see the V is equal to V of D is equal to 20 millimeter. This one is in the zero voltage reference. It means this is in the negative x-axis. The plane is in the negative x-axis, so we have to invert the final answer. So here the final answer will be at x of 0 millimeter we will have negative 2.2 voltage. So that's the voltage for the first one. Now for the second one, it's located at x is equal to 50 millimeter. X is equal to 50 millimeter. That is in the positive x plane. So the answer remains the same. We don't have to invert this one. So this is going to be just 3.3 voltage. And that's it. That's how we do this kind of problems. I hope this helps. Thanks for watching.